Interactive online training on piping and instrumentation diagram. Module 5. Symbology controls. Following topics to be discussed in this module. 1. Control system. 2. Control valves. 3. Control symbols. 4. Interlock and shutdown. 5. Function identification symbols. 6. Self-actuated regulators, valves, and other devices. 7. Control valves and actuators. Eight. Actuator action in event of actuator power failure. 9. Valve controls. 10. Quiz. A control system is a device or set of devices that manages, commands, directs, or regulates the behavior of other devices or systems. Industrial control systems are used in industrial production for controlling equipment or machine. Instruments attached to a control system may provide signals used to operate solenoids, valves, regulators, circuit breakers, or relays. These devices control a desired output variable and provide either remote or automated control capabilities. These are often referred to as final control elements when controlled remotely or by a control system. Control valves are valves used to control and regulate the conditions such as flow, pressure, temperature, and liquid level. They function by fully or partially opening or closing in response to signals received from controllers that compare a set point to a process variable, whose value is provided by sensors that monitor changes in such conditions. The opening or closing of control valves is usually done automatically by electrical, hydraulic, or pneumatic actuators. Positioners are used to control the opening or closing of the actuator based on electric or pneumatic signals. These control signals, traditionally based on 3 to 15 psi, 0.2 to 1.0 bar, more common now are 4 to 20 mA signals for industry. Blowdown valves, BDV. As the name implies, blowdown valve is used for the removal of solids or liquids from a container or pipe using pressure. A BDV is a tight shut-off valve, generally a ball valve, operated by a single-action pneumatic actuator. In operation, the actuator must be pressurized and the solenoid valve energized, and to blow down one must energize the solenoid valve to exhaust the actuator. Solenoid valves. A solenoid valve is an electromechanically operated valve. They are the most frequently used control elements. Their tasks are to shut off, release, dose, distribute, or mix fluids. The valve is controlled by an electric current through a solenoid. In the case of a 2-port valve, the flow is switched on or off. In the case of a 3-port valve, the outflow is switched between the 2 outlet ports. Pressure safety valve, PSV. PSVs are also known as pressure relief valve, or simply relief valve. The purpose of the PSV is to release overpressure automatically when operator is unknown, or not aware about the abnormal conditions which underwent before corrective actions could be taken up. PSV is operated by a mechanical action spring. Thus, PSV is independent of system failure. PSV is the ultimate safeguard when things go out of way and no one is able to control anything. Shutdown valve, SPV. A shutdown valve is referred to as emergency shutdown valve, ESV, ESD, or ESPV. SPV is an actuated valve designed to stop the flow of a hazardous fluid or external hydrocarbons, gases, upon the detection of a dangerous event. This provides protection against possible harm to people, equipment, or the environment. Shutdown valves are primarily associated with the petroleum industry, although other industries may also require this type of protection system. Shutdown valves form part of a safety instrumented system, SIS. SIS is another topic of discussion and beyond the scope of this course. Display indicator controller or other device. Software alarms with shared display device. When instrumentation symbols are integrated with squares and diamonds, they become control symbols. Shown below are the control symbols used on P&Id. Emergency shutdown, fire and gas, unit control panel. An interlock is the device used to prevent undesired states in a machine, which in a general sense can include any electrical, electronic, or mechanical device or system. In process engineering, interlock circuits and their components should be designed to actuate the final devices. For example, control valves, in the direction required to cause the process to fail safe upon loss of power. Operation of an interlock system may take place either through manual or automatic trip. A manual trip allows an operator to trip the system independently of the interlock system in the event of a hazardous situation developing. In a manual trip, the interlock system is manually actuated from a switch or push button, which may be located on a local panel, in the field, or in the control room. An automatic trip, as the name implies, is automatically activated when a hazardous situation is detected. A common example is the de-energizing of a solenoid valve that fails a control valve to its safe position. Below are the interlock and shutdown symbols represented by diamond are used on the P&Id. Outputs exist if all the inputs exist, or output exists if one or more of the inputs exist. No output exists if an input exists. Time delay. Output exists after preset time. Emergency. Logic performed in DCS. Purge or flushing device. Reset for latch type actuator. Functions are identified by symbols and/or initial letters. For example, if a summation is required, the Greek symbol sigma is displayed. Similarly, IA represents instrumenter. More function identification symbols are shown below. Bias. Multiplying. Dividing. High selecting. Low selecting. High limiting. Low limiting. Difference. Summing. Averaging. Square root extraction. English. Derivative. Function. Instrument gas. Instrumenter. Input-output of the following. Designation and signal. Analog. D-digital. E-voltage. EMF. G-gas. H-hydraulic. High current. MP millivolt. O electromagnetic. P pneumatic. R resistance. The control of process variables such as pressure, flow, differential pressure, or temperature requires three basic functional units. One measuring equipment, pneumatic transmitter. Two controller, pneumatic controller. Three final controlling equipment, control valve. These components make part of the control loop to perform their respective functions. These control loop components are separate devices that must be supplied with auxiliary energy. For simple pressure, flow, differential pressure, or temperature control tasks, such instrumentation setup is often too complex and, from an economic point of view, too expensive. For these applications, self-actuated or self-operated regulators can be used. The performance of work requires energy. Self-actuated regulators withdraw this energy from the medium to be controlled. Following are the symbols used for self-actuated regulators, valve, and other devices employed on the P&Id. Flange sizes and orifice type. Set pressure, kilo-pascal gauge. Pressure relief or safety valve. General symbol. Flange sizes and orifice type. Set pressure, kilo-pascal gauge. Vacuum and relief valve. General symbol. Flange sizes and orifice type. Set pressure, kilo-pascal gauge. Pilot operated pressure, relief or safety valve. Flange sizes and orifice type. Set pressure, kilo-pascal gauge. Pressure and vacuum and relief. Valve, spring, or wave loaded, or with integral pilot. Flange sizes and orifice type. Set pressure, kilo-pascal gauge. Safety valve. Pilot operated. Control angle valve. Manual angle valve. Motor operated valve. On-off operated valve. XV, bead EV, ESEV, or SEV. Hand control valve and process line. Set pressure, kilo-pascal gauge. Back pressure regulator. Self-contained. Set pressure, kilo-pascal gauge. Pressure reducing regulator. Self-contained. Rupture disc or safety head for pressure relief. Rupture disc or safety head for vacuum and relief. Hand control valve and signal line. Pressure and vacuum and relief manhole cover. All trap. Speed controller. Control valve speed actuators to operate. Actuators are either pneumatic or electric. Below are the symbols used for control valves and actuators on P&Id. Three-way solenoid valve. Solenoid valve with manual reset. Cylinder type, spring-operated single-acting valve with open-closed info. Control valve with diaphragm actuator. In the event of power failure, the commonly used failure modes are defined by the term shelf position. As an alternative to arrows and bars, the following may be employed. Two-way valve, fail open. Two-way valve, fail closed. Three-way valve, fail open to path AC. FC fail closed. FI fail intermediate. FL fail last position. FO fail open. The gate valve shown with the 3 control types below is for example purposes only. It can be replaced with other types in order to fulfill the service requirements. Control valve, diaphragm type. Regulating valve. Actuating valve, piston type. Can you recognize the instrument symbols shown below? Purge or flushing device. Shared display, shared control, auxiliary location normally accessible. High selecting. English. Instrumenter. Hand control valve and process line. Control valve with diaphragm actuator. Two-way valve, fail closed. Regulating valve. Three-way solenoid valve. At this moment, Module 5 ends. Symbology on equipment to be covered in the next module.